Hello everyone, welcome to the Learning Cubicle. In the last class, we have learnt spherical mirrors and some terms related to spherical mirrors such as pole, center of curvature, radius of curvature, focal length, principal focus, all these terms we have learnt. And we have also shown them in the diagram. And today, we are going to learn about the image formation by these spherical mirrors, that is concave and convex mirrors. But before we go to the image formation in these mirrors, let us first check our knowledge of image. So what we need to know is what is image? What is image? So image is nothing but it is a point or set of points where the rays of light after reflection either actually meet or appear to diverge from it. If I say this, you may not understand that. Let me show it to you in the form of a diagram. Okay? For this, let us go back to the plane mirror, the image formation in case of a plane mirror. Okay? So, this is how we represent a plane mirror. We have already learned that. This is how we represent a plane mirror. It has a plane surface and one of its sides is polished. Now let us imagine there is an object over here which is just like a dot. Just like a dot. Okay? And for us, the object is the source of light. So from the object, infinite rays come to the mirror. Let us suppose two of those rays are coming over here for simplicity and striking the mirror at these 2 points. These are the points of incidence. This is one point of incidence. This is another. Okay. Now at this point you can draw normal. We have learned about these earlier. Normal. And we know that angle of incidence is equal to angle of reflection. So this ray of light gets reflected that way and this ray of light gets reflected that way. Okay, and we know that these both rays can never actually meet because they are going one away from the other. Okay, but these two rays appear to diverge from a point somewhere inside. Let us do that by extending the rays of light backwards. So this is where the rays of light appear to come from. Okay, so these rays of light won't actually meet, but they appear to diverge from this point. And this point is what we call the image of the object. Of this object. So image is basically a point or set of points where the rays of light either actually meet or appear to diverge from that point. So if the rays of light are appearing to diverge from a point, we call that image as a virtual image. A virtual image. That's a virtual image. Whereas, if the rays of light actually meet after reflection, then we call such an image as a real image. As a real image. So, a real image is a point or set of points where the rays of light after reflection actually meet. Whereas a virtual image is a point or set of points where the rays of light after reflection appear to diverge from, which we have seen in case of plane mirror. So plane mirror forms a virtual image. So we will be learning in this class about the image formation in case of concave and convex mirrors, which are curved mirrors or spherical mirrors, right? Now, before we learn about the image formation in case of concave and convex mirrors, there are certain rules that we need to learn. But before we learn the rules, let me ask you a question, a very simple question. That is, why do we need to draw the images for concave and convex mirrors? Why can't we simply show it like how it happened in a plane mirror? What is so different between the image formation in case of concave and convex mirrors and plane mirror? There is a difference between that. In case of plane mirror, wherever the object is placed, the characteristics of the image will always remain the same. Wherever you place it from the mirror, the characteristics are going to be the same. It is virtual, it is upright, it shows left-right inversion. That means if you hold a pen in your left hand, in the plane mirror it appears as if you are holding it in the right hand. And the image is always the same size as the object. And the image will be at the same distance from the mirror as the object is in front of it. So these characteristics are same for whatever position of the object. But in case of concave and convex mirrors, it is not like that. It is not like that. That is the reason why we are learning about the image formation or drawing the geometric images for concave and convex mirrors. The reason being, as you change the position of the object, the characteristics of the image are also going to change. That is why we need to draw the image for different positions of the object in case of concave mirror and also in case of convex mirror, which we need not do for a plane mirror. So, since we know the reason now why we need to draw the image formation or draw geometric images for concave and convex mirrors, let us know the rules for drawing these geometric images. Let us know the rules. Alright. So, we have 4 rules for drawing the geometric images for concave and convex mirrors. There are 4 rules. And they are quite simple rules. And we have already discussed a couple of them while we are learning the terms related to the mirrors. Right? The first rule states that any ray of light which first passes parallel to the principal axis after reflection either actually passes through the focus or appears to diverge from it. We learned this already while we were learning the principal focus definition, isn't it? So, I am drawing here the concave mirror and I am drawing here the convex mirror. So, I am marking its pole and even its pole. Marking its center of curvature and even its center of curvature. Doing it simultaneously, okay? Marking its focus here. I am marking its focus here. So, as I said, the first rule, any ray of light which first passes parallel to the principal axis after reflection either actually passes through focus or appears to diverge from it. Concave mirror, it will actually pass through. I told you already. In case of concave mirror, it actually passes because of its shape. And in case of concave mirror, it appears to diverge from it. It is appearing as if it is diverging from this point. But here it actually passes through this point, the focus. So that's the first rule. And the second rule is quite opposite to this, or we can say the converse of this. That is, any ray of light which first passes through focus after reflection passes parallel to the principal axis. That means if the ray goes like this first, after reflection it goes parallel. If the ray goes like this first, after reflection it goes parallel. Then what about convex mirror? Same thing. Any ray of light which first appears to come from focus, after reflection goes parallel. If the ray is appearing to come like this, suppose if it is coming like this, then after reflection it goes like this. If it is coming like this, then it goes like this. So any ray of light which first passes parallel to the principal axis, after reflection goes through focus, and if any ray of light which first passes through focus, after reflection goes parallel, or if it is appearing to come from focus, it goes parallel, like this. Now let's see the third rule. The third rule states that any ray of light which first passes through center of curvature, this one. Any ray of light which first passes through center of curvature retraces its path after reflection. Retraces its path means goes back along the same path. The reason being, it strikes the mirror at an angle of 90 degrees. It strikes the mirror at an angle of 90 degrees. If this is the mirror, it strikes like this. So if it is striking like this, it is coming along the normal. So angle of incidence is equal to 0 degrees. So angle of reflection is also 0 degrees. So the ray goes back like that. That's the third rule. Any ray of light which first passes through center of curvature retraces its path because it strikes the mirror at an angle of 90 degrees. Similarly over here, any ray of light which is appearing to come from the center of curvature, if it is coming like this, it goes back like that. That's the situation there. Any ray of light which is appearing to come from the center of curvature, if it is coming like that, it goes back in the same path. The reason being the same, striking the mirror at an angle of 90 degrees. Okay? And the last rule, the fourth rule, any ray of light which first strikes the pole, means if it, this is quite confusing, I will draw the diagram again for you. So this is the concave mirror and this is the convex mirror, marking their pole. Marking its center of curvature, marking its focus. Okay. Now any ray of light which first strikes the pole, it gets reflected at the same angle. Whatever is this angle, at the same angle it gets reflected. At the same angle it gets reflected. The reason being, I told you earlier, the ray of light coming from the center of curvature is perpendicular to the mirror. So here principal axis acts as a normal. Principal axis acts as a normal. So then this angle would become angle of incidence and this angle would become angle of reflection. Angle of incidence, angle of reflection. And according to the laws of reflection, we know that angle of incidence is equal to angle of reflection. So the fourth rule states that any ray of light which first strikes the pole gets reflected at the same angle, because principal axis acts as a normal over here. So angle of incidence is equal to angle of reflection. Now using these rules, we will be drawing the geometric images for concave and convex mirrors. So we will learn the image formation using these rules now. Okay? Okay, let us first learn how to draw geometric images for convex mirrors. In order to draw these diagrams with a lot of precision and to obtain the image at the position where it is supposed to form, we use some geometry instruments like a ruler and even a compass, and sometimes we even use a protractor to draw these diagrams, right? And before we draw the geometric images or the image formation for convex mirrors, we need to keep certain things in mind. When we are drawing the mirror, we should make sure that we take a larger radius using the compass and then draw the mirror. And why should we do that? Why should we take a larger radius? Suppose if you take a very small radius like that, you end up drawing a semicircle, and when you mark the imaginary points like center of curvature, pole and focus, all of them come very close. And also when we position the object, the rays of light that are coming from the object may not be clear, and the position of the image may not be so clear than what you expected, right? So we need to take a larger radius, and then we need to draw the mirror and then mark all those points and proceed with the image formation. Okay, so first let us draw the mirror or the convex mirror with a larger radius using the compass. Now the point of your compass will rest at a point over here, and then we draw the mirror. It should be just like an arc. Okay, for much clarity I am drawing another layer on that. Okay, and this point where the compass rests or the compass needle rests is what you call as the center of curvature. This is the center of curvature. Okay, now using the ruler we join this center of curvature to the mirror. And we can extend this side and even backwards. And this point where the principal axis meets the mirror is what we call as pole, which is denoted by P. Since this is a convex mirror, the polished side will be towards the hollow side. Okay, now the midpoint of CP, or the distance between center of curvature and pole, will be the focus. So I am marking it over here exactly in the middle. So this is the focus. So we finished marking the center of curvature, the focus and the pole. Now we will be positioning the object. The first position of the object is at infinity. So object is at infinity means the object is very far from the mirror. Infinity doesn't mean that it is at an infinite distance. No. It is at a distance which is finite but very far from the mirror. Like for example, if the mirror is in your hand, the sun will be the object. We know that the sun is at a finite distance, that is few million kilometers from the earth, but we just call that as an object at infinity because it is very far. And moreover, another point that must be kept in mind over here is that when the object is at infinity, the rays of light coming from it are parallel to one another and also parallel to the principal axis. Now why? Why should the rays be parallel to one another and why should they come parallel to the principal axis? It's because, let us suppose the wall over there is an object. When I am close to the wall, the rays of light coming from the wall are divergent. They come divergent. Whereas when I move from it, the rays of light coming from the wall tend to become parallel to one another. And that is why we must consider the rays of light coming parallel to one another and also parallel to the principal axis. And another thing that must be kept in mind whenever the object is at infinity, in case of any mirror, convex or concave, we should not represent or show the object in the diagram. Now why? Why shouldn't we show the object in the diagram when the object is at infinity? It's because if we show the object over here, it clearly shows that the object is very close to the mirror. But we said that the object is very far from the mirror. So for that reason, we don't show any object when the object is at infinity in case of convex or concave mirrors. Now, so let me suppose the rays of light coming parallel to the principal axis. I am drawing one ray. One ray parallel to the principal axis, and this is another ray coming parallel to the principal axis. This is another ray, and this is another one. Now there are 4 rays I have drawn, and according to the rule, whenever a ray of light passes parallel to the principal axis, after reflection either actually passes, if it is a concave mirror, or appears to diverge from the focus if it is a convex mirror. So they should appear to diverge from focus. So first let us mark the points of incidence, and using the ruler we will join these rays of light, these points with a dotted line as if they are appearing to diverge from the focus. So they are appearing to diverge from the focus and they get reflected like that. See, this ray is appearing to diverge from here. Similarly, this one. Now you can see here all these rays are appearing to diverge from the focus, and hence the image will be formed at the focus. So when the rays of light are coming from infinity, they get reflected from the convex mirror and all of them appear to diverge from focus. So that is the first position of the object in case of convex mirror when the object is at infinity. Alright, so now let us see the characteristics of the image formed when the object is placed at infinity in front of a convex mirror. Right? So the first one, position of object is infinity, and nature of image The rays of light are not actually meeting after reflection. They are appearing to diverge from this point which is focus. So the image will be virtual, and a virtual image is always erect. So the nature of the image is virtual and erect. Now coming to the size of the image, you can barely see the image over here. It's just like a dot. It has merged with the focus. So image is basically diminished to a point. Diminished means reduced. It's reduced to a point. It's looking like a dot. So image is diminished to a point. And finally, the position or location of the image. Where is the image formed? The image is formed, you can see over here, it is formed at principal focus, that is behind the mirror. Okay, so it is formed at F or principal focus behind the mirror. So these are the characteristics of the image formed when the object is at infinity in front of a convex mirror. So now we will be moving on to the second position of the object, that is when the object is anywhere between infinity and pole. So let us see how to draw the image formation in case of convex mirror when the object is placed anywhere between pole, infinity and pole. Okay? Right. Now let us draw the image formation for the second position of the object, which is the object is anywhere between infinity and pole, okay, which is a finite distance. That means the object is at a finite distance from the mirror. That means it's very close to the mirror. So we will position an object over here. In this diagram we will show the object because the object is closer to the mirror now. Now we will show the object over here. So we will draw an object. An object is represented by a straight line having a head, an arrowhead you can say, and a tail. An arrowhead and a tail. Now why should we show an object like this only? Why can't we show it with simply like a line? If we show it simply like a line, you do not know whether the image is erect or inverted, because an erect image will be like this and inverted image also will be like this. You cannot make out which is erect and which is inverted. Suppose if the object is like this and the image is like this, you can make out that the image is inverted. And if the image is like this, you can make out that the image is erect. So that is the reason why we show the object with a head and a tail. Now from the object, infinite number of rays come and hit the mirror. But we cannot show all those rays of light. So we will only show 2 or 3 rays for simplicity or to avoid complexity. Okay. So we will draw 2 rays coming from the object and hitting the mirror. So one ray we will take parallel to the principal axis. That is like this. I'm drawing here, you can see. One ray of light is hitting the mirror and coming parallel to the principal axis, and this is its point of incidence. And another ray I will draw from the object to the pole. Okay, so something like that. So this is the second ray of light that is coming and hitting the mirror at the pole, and this is its point of incidence. Now according to the first rule, any ray of light which first comes parallel to the principal axis after reflection appears to diverge from the focus. So again, what we did in the previous diagram, the same thing we are going to do. We are going to draw the rays of light appearing to diverge from the focus. So this is the first ray of light which is getting reflected and appearing to diverge from the focus. Now, what about the second ray? Any ray of light which first strikes the focus will get reflected at the same angle because the principal axis acts as a normal. Now, let us first measure this angle. How much is this? We will see this angle is 38 degrees. Okay, so we will mark the same 38 degrees even this side. 38 degrees even this side. That is somewhere over here. So we will draw the ray at the same angle. Now, this ray and this ray can never meet, but they both appear to diverge from a point this side. Let us extend this ray backwards. That is from here. They appear to diverge from this point over here. So, this is the point where the image is formed, and the rays of light are coming from the head. So, the head is formed over here, and a virtual image is formed over there. And you can see here the image is erect, the image is smaller than the object, so it's diminished. Right. So let us see the characteristics of the image formed, and the object is anywhere between infinity and pole. We know that the rays of light are appearing to diverge from this point, so they are not actually meeting. So the image is virtual and erect, just like the previous case. And the image is not diminished to a point, but it is definitely smaller than the object. So it is just diminished. The image is diminished. Okay. And where is it formed? It is formed between F and P, and that is behind the mirror. So image is formed between F and P, that is focus and pole, behind the mirror. So this is how the image formed will be. These are the characteristics of the image formed for the second position of the object in case of convex mirror. Thank you so much.